While Alex is racing offshore, particularly in longer races like the Vendée, remaining connected is super, super important for a whole variety of reasons. The first thing is actually being able to perform well in the race. So you need to be able to get the position updates. So knowing where your competitors are on the race course, and this will happen every few hours, but you want to get it as soon as it comes out. Downloading weather. So this involves downloading, basic grid files that come out on intervals, but also being able to download satellite imagery, real-time weather observations, all sorts of weather files and forecasts that you use to make your decisions. And there's times where something's changed and you need to download a weather file right then. And then there's several other reasons that it helps him both mentally and also from a standpoint of making the race interactive. So Alex wants to be able to communicate with his family, with his friends, with the team, so he can feel not so alone out there. And this is a really important thing. And also connecting to fans and everyone else on shore. So sending media back, doing live interviews, sending pictures, and being able to do this reliably, easily, and on a regular basis, it makes the race come alive for the folks back home. And without that, a big part of what we're doing, people would never be able to experience. When we started our partnership with Nokia, with them being involved in mobile infrastructure, connectivity in general, the whole idea of how could we make the boat more connected to shore, that came up as a point right at the very beginning.
The first part was really just to get a baseline on the performance of the communication capabilities and the satellite communication that Alex had on the boat at that time when we started working together in 2018. So for the Route du Rhum, we started taking measurements of the performance, the throughput. So this is about how much data you can send at any point in time over the satellite link, how long it takes to send the data, so throughput and latency tests, as well as reliability, dropouts on the connectivity. So we started measuring all of that during the Route du Rhum in 2018 to really understand what's the baseline and where are the pain points, specifically in a quantitative way, not just in a qualitative way. So then we looked at how can we improve it? How can we improve the reliability? How can we improve the robustness? How can we reduce the latency? And how can we improve the throughput? And so we really looked at it holistically and what are the options?
In this cycle of the Vendée, we're using a completely new type of satellite connectivity. So previously, we almost always, for a high-speed connection, used a network called Inmarsat. And Inmarsat worked off of what are called geostationary satellites. So there's only a small handful of satellites, and they're designed to stay over a specific point on the planet all the time. So depending on where you are, the antenna actually has a little internal part that locks onto the satellite, and then as you move along, it keeps pointing at it. This network's been around for quite a while, works reasonably well. The speeds are somewhat restricted, but it's what most of us used offshore sailing for the better part of a decade. And then just recently, the first satellites were coming online in early 2019. The Iridium Certus network went up and went live. And this new network promises faster speeds. It's much, much cheaper in terms of available data. So you can use a lot more data, which means we're able to stay online, stay connected much more than ever before. And then the hardware that we're using for that is made by a company called Thales. And they've recently developed this hardware specifically for the marine market and specifically for this Iridium Certus network. And so their hardware is quite light, very robust, and it's designed exactly to be used with this new technology.
When we look at the architecture of the system, you have to understand the constellation of the Iridium satellites, and it's a constellation of 66 satellites in low Earth orbit that rotate around the Earth on polar planes. So at any point in time, it's not you don't always have a connectivity to the same satellite. The satellites rotate, and as Alex is sailing around the world, he will not always be connected to the same satellite. And so it's really a question of where the boat is, how do we make sure that he sees a satellite in a reliable way? And that really drove a lot of the architectural thinking in terms of, should it be one satellite receiver on the boat or should it be multiple satellite receivers? And given the layout and the configuration of Hugo Boss, what's the best placement for the satellite receivers? And so we spent really a lot of time thinking through that. And obviously there are considerations in terms of size, weight, power consumption if you go to multiple receivers. If you look at the back of Hugo Boss, you'll see that there are two receivers. a lot of the boats have just one, and a lot of boats have one, and it's placed in the back of the boat at the center of the boat, which is the natural position to place a receiver if you don't think about the boat heeling. But when you think about the boat heeling, we decided to place two receivers and separate them and put them on the side of the boat. And then the other thing that we've done is also not place them straight, but angle them at a 15-degree facing outwards. So if you imagine when the boat is straight, the receiver is actually positioned this way. But when the boat is heeling, now that starboard or port receiver, depending on which way the boat is heeling, will point up straight at the sky. And the 15 degrees is a decision we made because the heel angle is very often between 10 and 20 degrees. And we've done a lot of computer simulations to calculate what the best position would be and what the best angle for the receivers would be, and then we placed it on the boat. And we've not seen anybody who's done anything like this on looking at where the receiver should be placed. And we think that's quite unique and really one of the keys to give us that performance improvement.
Over the course of the Vendée, we were able to have Alex remain more connected to shore than ever before. And there's a lot of reasons for that. One is that we do have more available bandwidth on a regular basis. So this means that, sending large video files whenever he wants, that's straightforward. You can just press go and wait, and next thing you know, 5-minute video has come through to shore. But also, because of the reduced cost and stable connection, the boat's online pretty much 24 hours a day. So what this means is that actually on the boat, Alex is running WhatsApp. And this level of connectivity is unbelievable compared to anything we used to do. And all of this is it's a huge departure from where we were at, 5 or 10 years ago.
Alex commented that he'd never been able to have a 40-minute WhatsApp call with his family without it being interrupted. And he was incredibly pleased with the amount of data that he can send, the reliability of that without him having to reconnect, the stability, the robustness of the connection. All of those made really, really big differences.
As a technical team, we're allowed to support Alex and help him repair the boat during a race. So for example, in this Vendée, when he had structural failure in the bow, Alex was able to send very, very good descriptive videos quickly off the boat that showed us everything about what was going on. And these are very large files. Some of them are 300, 400 megabytes, and we don't really struggle with that anymore. So we can get that off the boat. Shore team can assess very accurately what's going on, and then can send back pictures, videos, documents to describe what he needs to do the repairs. And it works in a cycle. So he'll make a repair, he'll send back some feedback. We'll then go back to him with what could be done differently, what else needs to be done, what are the next steps. And without that loop of being able to stay connected and reliably communicate back and forth in a quick and easy way, we wouldn't be able to support these crisis situations nearly as effectively.
This was really not a trial and error project for us. This was really, we think through it, we come back with the architecture, we do a lot of calculations and simulations. We come back with a recommendation of where the receivers go, the angle we should place them, and when we then started testing it, it worked exactly the way we predicted in calculations and simulations. The scientific method we applied to this project was very unique and really gratifying to see how we think through the problem, we come up with the answer, and it actually exactly worked the way we anticipated in one go. Mission critical communication is super important, not just for Alex, but in a lot of other enterprise industrial environments. If you think Alex is in a remote area, it just happens to be on the ocean, but there are a lot of industrial sites that are very remote. If you think about oil rigs, offshore mines, remote wind farms, and all of those environments really rely on having that communication capability, that mission critical connectivity. So our ability to learn in the most extreme and difficult environments that Alex faces really helps us improve the capability we provide to our enterprise and industrial customers and partners.